This is the law of sines. We use it whenever we have angle, side, angle, or angle, angle, side. You'll also see law of sines written like this. So I'm going to do an example applying law of sines. I'm just going to draw a triangle. It won't be to scale, and it won't be perfect. This is angle A, angle B, which is 30 degrees, and angle C, which is not given. Across from angle C is side C. Angles and sides are always across from each other. So if this is angle A, that means this is side A, which was not given. So a triangle, all the angles of a triangle add to 180. So if I subtract 40 and 30, I'll get 110 degrees, which is this angle right here. So I found angle C. Now, using the law of sines, I can use either of these. These mean the exact same thing. This first one up here, they put the sides on top and the angles on the bottom. And then this one down here, they just put the angles on top and the sides on bottom. They're still the same ratios. Okay, so I am going to do the law of sines. I'm going to do side C over sine of angle C. And I'm going to go ahead and find side B. And I'm going to put that over sine of 30. Now I can go ahead and solve for B. So I'm going to multiply both sides by sine of 30, sine of 30. And if you type this into the calculator, make sure your calculator is in degrees or you will not get the right answer. Make sure it's in degrees. Okay, so I typed this into the calculator and I got 5.32089. That is what side B is equal to. Now you can use the law of sines again to find side A. You would just set it up like this. 10 over sine of 110 is equal to side A over angle A, sine of angle A, which is 40. And in the same way, multiply both sides by sine 40. Type this into your calculator and you'll get what side A is equal to. So guys, this is an example of, angle, side, angle. Those are the three details they gave you. Angle, side, angle. That works very well with law of sine. Now, we're going to look at the case where we get SSA. Whenever you get side, side, angle, every time I want you to just go ahead and figure out the amplitude. Amplitude means the height. So what you're going to do is just draw a line perpendicular and form a right triangle. And I'm going to go ahead and give you the three pieces of information. Let's say that this side is 30. No, I'm going to change that. Let's say that this side is 10 inches. This side is 3 inches. And this angle is 30 degrees. And we're going to draw a right triangle in this here. And I'm going to call this the height. We need to find the height. Whenever you're given SSA, just go ahead and find the height. So if you remember from the last unit, if I take sine of this angle right here, it would be opposite over the hypotenuse. So I can go ahead and solve for the height. Multiply by 10 on both sides. So if I put that in my calculator, you get 5. So the height here is 5. Now, if you look at this picture, that makes no sense. Let me explain why. I gave you a side and an angle. Those are permanent. Those may not change. This angle right here is locked in. That's why I put a lock right there. You cannot change that angle. However, we didn't tell you about the other angles of this triangle. So I can move this angle if I want to. I want you to imagine this side just swinging back and forth. This will never form a triangle. It will never be long enough. Okay? You can't change this length. it was given to you as 3 inches. You can't change this length. It was given to you as 10 inches. And if you swing this, it will never form an angle. If you swung it right here, it would only reach to here because it's only 3 inches long. Does that make sense, guys? So visually, there is no triangle because it will never close and it will never enclose the shape. Also, if you didn't want to do it visually, we see that there's no triangle, and the reason is A is less than the height, so it's no triangle. If you don't want to do it visually, just use the law of sines. So I told you that this was 30 degrees, this was 10, and this was 3. If I do law of sines, we put 3 over sine of 30 equals 10 over sine of B. Let's see if this is an actual angle or not. So go ahead and do some algebra. I can cross multiply. This is 10 sine of 30 equals 3 sine B. Divide by 3. And if I put that in my calculator, I get 1.66667 equals sine B. And if I want B, just take the inverse of both sides. So sine inverse, those cancel. So B is equal to, if you type this into your calculator, it's going to give you undefined. So again, no triangle. You see it algebraically through law of sines, and you see it visually because A is smaller than the height. It won't close. Here's another case. If I say this is 30, this is 10, and we saw that the height, when we solved it, let me go back. We said the height here was 5. Okay, I'll do the same type of triangle. The height is 5, and I'm going to say that this is 5. So when you swing it right here, it's going to form a right triangle. So that's also a possibility. It all depends on what this length is. So if A is equal to H, it'll form a right triangle. Next example. Okay, here's my next example. I'm going to tell you that this is still 10 inches. This is still 30 degrees, and my height is still 7. I'm sorry, it was 5. My height is still 5 inches. Okay, now let's say that A this time is equal to 7 inches. Remember, this 10 inches and this 7 inches will not change. That was given, it's permanent. This angle will not change. However, other stuff can. I want you to look and see what I can do. This is one triangle. I'm going to draw one triangle that I have. This is the triangle you see here. This is 7 inches, this is 30 degrees, and this is 10 inches. The tricky thing about side A is that you can possibly form 2 angles. So let me show you. I'm not going to change the height. I'm not going to change the length of 7 inches, but I can, I can form another triangle if I rotate it. There we go. That's my second triangle that can form. And it's still 10 inches, 7 inches is the length, and I still have the 30-degree angle. That's 2 possible triangles with that side angle, right? Those are 2 possibilities that I just showed you. So the other triangle that has the same criteria, this is still 10 inches, this is still 7 inches, and this is still 30 degrees. So that was 2 angles formed. You will see 2 angles formed whenever your A value is between the height and between this B value. So whenever A is bigger than the height but less than the other side, you're going to have 2 cases, and you'll have to solve for both. Okay? So I'll do an example where we solve for, since I already have it on this screen, I'll go ahead and use law of sines to figure out these different cases here. So what I'm going to do, I know this is 7 inches. So if I want to figure out this side right here, I can do sine of 30 over 7 equals 10 over sine of b. This is b. And then put that into your calculator. Multiply by 10, multiply by 10. Let's see what I get. You get sine of b is equal to 0.714286. All right, now just take the inverse of both sides. So take the inverse, that cancels, take the inverse of this. So if you type this into your calculator, let's see what you get. Sine inverse of 0.714286 is 45 degrees. All right. So what I want to show you guys, do y'all see this picture that I just drew? I actually showed you, let me put it back. Okay, that's actually this angle here. Because look at my triangles. This one's an obtuse angle. And this one's an acute angle. So this angle is 45.5847. Remember the other triangle? It looks like this, right? This is still 7 inches. This is an isosceles triangle. This side is 7 inches. It did not change, and I just swung it over here to create another triangle. These are both 7 inches. If this side is equal to this side, that means this angle is equal to this angle. So if this is roughly 48 degrees, then that means this one is 48 degrees. This is on a straight line. So what is this obtuse angle? How would you find it? Exactly, 180 minus 45, and I'll be exact, it's 45.5847. So if I put that in my calculator, 45.5847. Okay, so this obtuse angle is 134.415 degrees. Okay, so I'll call this angle B prime, and I'll call this one just B. So those are your two different ones. And you can use law of sines to figure out the rest of your triangle and the rest of the sides. Okay? All right, last case I want to show you, I think this is a long lesson, is whenever A is bigger than B. So in this example, I'm saying that your A value is 12. This is B, still 10. When it's bigger, it's just going to form one triangle. You can rotate this so that it closes and forms one triangle. And then use law of sines to figure out the rest of the information. So in your notes, guys, you have this problem. Go ahead and try to do, let's do this one. Try to do this problem in your notes, and then we'll come together. All right, this problem, if I do it algebraically, I can do 5 over sine of 62 equals 15 over sine of b, and then I'll cross multiply. Divide by 5. Okay, so if I type this into the calculator, I get 2.64884. And guys, the range of sine is from -1 to +1, so that is not inside of the range. But if you wanted to keep going, to be sure, the inverse of both sides, take the inverse, those cancel. So b is equal to the inverse sine 2.64884, and it's going to come at as undefined. So since it's undefined, this is not a triangle. Another way you could have seen this is if you draw it, this is 62 degrees, this is 5, and this is 15. If you calculated the height, which is sine of 62 of h over 15, multiply by 15. 13 point what? 2, 4, 4, 2. This is less than the height. That's not possible. It wouldn't form a triangle. So this is no triangle. You can either do law of sines to see it, or you can find the amplitude, the height of the triangle, and see that this A value is less than the height. That's not possible. Okay, again, I'm giving a side, and an angle. A side, and an angle. Okay, make sure 99 degrees, which is angle A, is across from side A, which is 9.2. Okay, so what I'm going to do is I'm going to just, I can do many things. I can do law of sines. So let's see. Sine of 99 over, or with 9.2, 5.5 sine B. I can cross multiply. And then I can divide by B. Divide by 9.2. I'll go ahead and put this in the calculator. Okay, I got 0.590466 equals sine B. If I want just B, I'm going to have to do the inverse so that those cancel, and the inverse of this side. So type this into your calculator. All right, so I got 36.1901 as angle B. So I'm going to go ahead and put that across from, this is side B, so that means angle B is down here. This is 36 point, I'll just round it up to 2, okay? So guys, this makes sense because I haven't equaled 180 yet, right? All three triangles have to add up to 180. So 99 plus 36 point, and I'll use the exact one, 1901, and subtract it from 180. That means this missing angle is 44.8099. Okay, so that's one triangle. That works. You can use law of sines to find the other side. Now, this is the part that I want you to understand. Let's figure out if there is a second triangle or not. Remember, this would stay the same. I can rotate it so that it looks like this, right? I form an isosceles triangle. So if this is 36.2, then this is 36.2. So then what would this obtuse triangle be? 180 minus 36.1901 is 143.81. Does that triangle make sense? If triangles add up to 180, does this triangle that I tried to form make sense? No. That means there's only one triangle, the one that I originally drew. Does that make sense? Okay, because look, the triangle that I drew right here in blue, this was still 99 degrees. I didn't change that. This side is still 9.2. I didn't rotate. I just rotated it. This is still 5.5. But that cannot be 143 degrees because all three angles have to add up to 180. So that means this other triangle does not exist. So you only have one possible triangle. Try the last one. Let's see. That was the last one? Oh, okay. This is the last one? Okay, great. Try that one.